Hi, in this video, I'll show why the golden ratio is equal to that number. That complicated number, which in decimal form is around 1.618, etc. The golden ratio was determined by the ancient Greeks as some sort of divine proportion that they believed was special. By the way, they never said that the golden ratio is any more beautiful or less beautiful than other ratios. They just thought it's special. The whole thing about the golden ratio looking good is a myth. But that's the topic for another time. Let's now talk about why the Greeks thought this ratio was special. Let's consider a different ratio. Let's take a 2-to-1 ratio. Why wasn't that ratio the golden one? Here's why the Greeks didn't think this ratio was special. Take a 2-to-1 rectangle. One side is 1, the other side is 2. Now build a square on the side of it. This side is 2, and therefore this side is also 2. Combined together, you have a big rectangle that is 3 to 2. That's equal to 1.5 to 1. You started with 2-to-1, and you ended up with 1.5 to 1. The ratio has changed. The Greeks thought that means it's not special. Okay, what if we take a shorter rectangle, take a 1-to-1 rectangle? One side is 1, the other side is also 1. And now we build a square on the side of it. This new square had this side equal to 1, and therefore this side is also equal to 1. And combined together, we have a 2-to-1 rectangle. We started with 1-to-1, and we ended up with 2-to-1. Again, the Greeks thought that since the ratio has changed, it's not special. Or look at this, for a 1-to-1 rectangle, after we build a square on the side of it, the ratio went up to 2-to-1. If we started with 2-to-1, it goes down to 1.5 to 1. So the Greeks suspected that somewhere in between 1-to-1 and 2-to-1, there's a ratio somewhere in the middle where if we build a square on the side of it, the ratio doesn't go up or down. It will just stay the same. They asked this question: what kind of ratio can we start with that if we build a square on the side of it, we end up with the same ratio? That's how ancient mathematicians like Euclid defined the golden ratio, as that the new ratio is the same as the old ratio. All right, so we wanted a blank to 1 ratio, and we don't know what the blank is. Let's call it x. We want a rectangle that's some sort of x-to-1 ratio, and we build a square on the side of it. And we're hoping that the new big rectangle is also x-to-1. Okay, so in this square, this side is x, and therefore that makes this side also x. The big rectangle is going to be x plus 1 to x ratio. So the new ratio is x plus 1 to x. And we want it to stay the same as the old ratio of x to 1. That leads us to this math problem. We want x plus 1 over x to be equal to x1. Let's solve for x. You can think of it as cross multiplying, or you can think of it as multiplying both sides by x. Either way, you get x plus 1 is equal to x squared. So we subtract this both sides, minus x and minus 1. You get x squared minus x minus 1 is equal to 0. That's a quadratic equation, and therefore we can solve with a quadratic formula. Minus b plus or minus square root of b squared minus 4ac over 2a, where a is 1, b is negative 1, and c is negative 1. Negative b, negative 1 is just 1. Plus or minus square root of b squared, negative 1 squared is positive 1. Minus 4 times a is 1, c is negative 1. Over 2 times 1. Work all of this out, you get x equals 1 plus or minus square root of 5 over 2, which is either equal to 1 plus square root of 5 over 2 equals 1.618, etc., or 1 minus square root 5 over 2, which is negative 0.618, etc. Our x is the length of a side of that rectangle, so it cannot be negative. We do not take the negative answer, we only take the positive answer, and therefore the ratio that we want is 1 plus square root 5 over 2. This is the golden ratio, and in honor of the ancient Greeks, we denote it by the Greek letter phi. Some people pronounce it phi. And that's the story of why the golden ratio is equal to that number. Hope you had fun. Any questions? Put it in the comments below. Like and share, and subscribe for more contents. Thanks for watching. Bye.